Hello and welcome. In this lecture, we are going to talk about different types of matrices. Alright, so let's start with the first type, which is square matrix. Now, what is a square matrix? A matrix in which number of rows is equals to number of columns. So for example, if we have a matrix 2, 1, 3, 5, this matrix is in the order of 2 by 2. Since number of rows is equals to number of columns, therefore we can say this matrix is a square matrix. Similarly, if we have matrix B as 1, 1, 1, 3, 1, 2, 5, 1, 5. If you see the order of this matrix is 3 by 3. Again, you can say this matrix is a square. Similarly, if we have a matrix with entry 5, since this matrix is 1 by 1, therefore we can say this matrix is a square matrix. In this series of lectures, our focus is on 2 by 2 square matrix. Let's talk about 2 by 2 square matrix and the structure of 2 by 2 square matrix. So let's suppose we have matrix A with entries small a, small b, and c and d. This square matrix has a very specific structure. Now, what the structure is, entries A and D are called entries of a main diagonal, and C and B are considered as entries of the secondary diagonal. Alright, so AD is the main diagonal, CB is the secondary diagonal, and if I ask you to identify the elements of the main diagonal, elements or members or entries of the main diagonal are A and D, and if I ask you to identify the entries of the secondary diagonal, then entries are C and B. Alright, so this is about the structure of 2 by 2 matrix. Alright, so next type is of identity matrix. And we represent identity matrix by uppercase I. Alright, so what is the definition of identity matrix? Since we are focusing only on 2 by 2 square matrices in our lectures, therefore based on that assumption we can say a 2 by 2 matrix in which entries of the main diagonal are unit or 1 and entries of the secondary diagonal are 0. We call this matrix identity matrix, and we can also call it the multiplicative identity in matrix algebra. Why we call this identity matrix a multiplicative identity? It's because when we multiply any matrix with identity matrix, provided multiplication is true, we will get that matrix. Alright, so if we multiply A with identity, we will get A. If we multiply B with identity, we will get B, and so on. Alright, so let's suppose we have one matrix 2, 1, 5, 6, and we are required to multiply this matrix with identity. We can state the resultant of the multiplication of these two matrices even without multiplying. Why? because we are multiplying A with identity, and we know that when we multiply any matrix with identity, we will get the same matrix. So in this, we can state the result as 2, 1, 5, 6 even before multiplying. Now let's talk about the third type. It's called null matrix. What is null matrix? A matrix of any order will all entries 0. Alright, like 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and so on. We represent null matrix by using uppercase O, alright, and we can identify null matrix as the additive identity in matrix algebra. What is additive identity? When we add any matrix with a null matrix, provided addition is true, we will get the same matrix. Alright, so let's suppose we have matrix A as 5, 1, 3, and let's suppose we have equation A plus B is equals to A, alright, where A is 5, 1, 3. Now if we are asked to state the matrix B entries, since we are getting the same matrix 513 when we add 513 with B, therefore B should be a null matrix, and B, order of B should match with order of matrix A. So therefore B matrix should be 0, 0, 0 in the order of columns. That means order of B should be 3 by 1. So this is about the null matrix. Alright, next type is inverse of a matrix. Now this is the most important type in matrices. We represent inverse of a matrix by using a small this -1 symbol in post superscript. Alright, so let's suppose if we have matrix A and we are interested in finding its inverse, we represent it by this thing. We read this as A inverse. Don't try to read this one as A raised to the power 1. It's wrong. It's simply the set a matrix notation, and we can say it's inverse of a matrix A. Now before going into the details of discussing the procedure of finding inverse, there are some key points to remember. Point number 1, inverse is defined for square matrices. Alright, so in our case it's only for 2 by 2. Key point number 2, inverse of a matrix is actually a multiplicative inverse of a parent matrix. What does it mean? When we multiply any matrix with its inverse, answer is always identity matrix or 1001 matrix. Alright, now let's talk about finding an inverse. Formula for finding an inverse is adjoint of matrix A divided by determinant of A. So formula of finding inverse has two components. One is adjoint of A, which is itself a matrix, and determinant of matrix A, which is called the magnitude of a matrix or the scalar quantity of a matrix. In step 1, we need to find the determinant or magnitude of a matrix. Alright, so the formula for finding determinant of a matrix is product of the members of main diagonal minus product of the members of secondary diagonal. So let's take one example. Alright, now in this particular matrix we can easily identify the entries of the main diagonal, which are 5 and 2, and entries of the secondary diagonal as 3, 1. So if we want to find the determinant of this matrix A, we can say 5 times 2 minus 1 times 3, that is 10 minus 3 means 7. Alright, so remember one thing, this particular modulus thing doesn't show that it's at an absolute value. This determinant can be positive or can be negative. Alright, step 2. Alright, one thing before starting step number 2, if determinant of a matrix is equals to 0, then since determinant in inverse formula, determinant is in the denominator and anything divided by 0 is infinity, so if determinant of a matrix is 0, then we can say inverse of that particular matrix is not possible. Alright, so this is very important point which you need to remember, that whenever the determinant of a matrix is equals to 0, then we can say inverse of that matrix or inverse of that square matrix is not possible, and that kind of matrix is called singular matrix. Means a matrix whose determinant is equals to 0. Alright, now step 2. After finding the determinant of matrix A, which is 7, in step 2 we need to find adjoint of A. Remember, adjoint of A is itself a matrix, and how we can generate this adjoint? We just need to interchange the members of the main diagonal and reverse the signs of the members of secondary diagonal without interchanging them. Alright, I'm repeating it. Interchange the members of the main diagonal means writing 2 in place of 5 and writing 5 in place of 2, and reverse the signs of the members of secondary diagonal without interchanging them. So we have 1 and 3 in our original matrix, so we have to write minus 1 and minus 3 in our adjoint matrix. Alright, and step 3, we need to put both the pieces of the puzzle into the formula. Alright, and this is the concept of multiplying a matrix by a constant. So we need to multiply all entries of adjoint, divide all entries of the adjoint by the determinant. So this is our inverse. Alright, so the key point which you need to remember is when we multiply any matrix with its inverse, answer is always identity matrix. Since we are focusing only on 2 by 2, therefore resultant should be 1 0 0 1 in all cases. Alright, now let's do some practice problems regarding inverse and analysis of inverse of matrix. Now we are required to find the value of K such that B is an inverse of A. Alright, since we know that when we multiply any matrix with its inverse, answer should be the identity matrix, therefore K should be 1. Alright, let's do another problem. Let's suppose we have matrix A with the entries 3k, 2, 1. Now it's given that determinant of matrix A is 0, or it's given that matrix A is singular. Alright, so if matrix A is singular, then we can say that determinant of that matrix is 0, means 3 times 1 minus 2 times k should be 0, means 2k is equals to 3 and k is equals to 3 over 2. Alright, let's do one more example. If we have matrix A with 2 minus 1 k 3, and given that determinant of a matrix is 5, based on this given data we need to find the value of k. So first we need to find the expression for the determinant, product of the members of main diagonal minus product of the members of secondary diagonal should be equals to 5, means 6, plus k is equals to 5, means k is equals to minus 1. Alright, so these are some examples related to inverse and analysis of inverse. Let's talk about some few other types of matrices. So type number 5 is singular matrix. We have already discussed it in our inverse analysis. What is singular matrix? A 2 by 2 matrix whose determinant is equals to 0. Alright, next is column matrix. Now what is column matrix? A matrix with exactly one column available, right? Like 1, 4, 5, 1, 2, and you can basically see this type of column matrix mostly in vector analysis as well. And the last type of matrices is row matrix. Now what is row matrix? A matrix with exactly one row. Alright, so a type of matrix with the order of 1 by m, and for column you can say a type of matrix with the order of m by 1. Alright, so for row matrix we can write 1, 4 as an example, or 1, 3 minus 5. So both of them are a kind of row matrices, right? So that's all for this lecture. Thanks for watching and happy studies.